You have probably seen the cartoons of the old viral videos where a chameleon steps on a checkerboard or a neon pink surface and instantly mimics it like a living photograph machine. And if you ask most people how they do it, they will tell you,
they just color paint inside around this.
Then it turns out almost everything we think we know about lizard color change is completely wrong. They don't copy their background, they aren't using paint. What they are doing is actually very cool. They are manipulating quantum physics and structural engineering in real time. Today we are cutting open the biological matrix to look at the insane science of how lizards actually change color. To understand this wizardry, we have to look under the microscope. A lizard's skin isn't just one surface. It is a highly organized three-layer biological sandwich made of cells called chromatophores.
First, you've got the top layer. This layer contains actual chemical pigments. You have xanthophores, which hold yellow pigment, and erythrophores, which hold red pigment. This is the only layer that works the way you think it works. Skip the middle layer for a second and look at the bottom layer. This is packed with melanophores, which contain melanin, the exact same dark brown and black pigment that protects human skin from the sun. Think of this layer as a biological dimmer switch. But the real magic? It happens in the middle layer. This layer is made of cells called iridophores. And here is the kicker. There is zero color pigment in this layer. It is completely colorless. Instead, it is packed with millions of microscopic, nano-sized crystals made of a substance called guanine.
Wait, if the middle layer has no color, how does it make the lizard change color? Welcome to the mind-bending world of structural color.
In the physics world, color isn't just about chemicals. It's about how light bounces off shapes. When a chameleon is completely relaxed, chilled out, and minding its own business, those tiny nanocrystals in its middle layer are packed super tightly together in a perfect geometric grid. When white sunlight hits this tight grid, the spacing mathematically interferes with the light, absorbing most colors but reflecting short wavelengths, specifically blue light. Now do the math. The middle layer bounces blue light upward. That blue light travels through the top layer, which is full of yellow pigment. What happens when you mix blue light with a yellow filter? You get green. That beautiful leafy green camouflage color isn't a pigment at all. It's an optical illusion created by physics. But what happens when the lizard gets angry or sees a rival male? It tunes the crystal grid. By stretching or relaxing its skin, the lizard manually changes the distance between those nanocrystals. If it pushes the crystals further apart, the grid stops reflecting blue. Instead, it starts reflecting longer wavelengths of light, like yellow, bright orange, or neon red. Literally, by flexing its skin, the lizard is shifting the gears of light physics.
But how do they do the dark moody colors? That's where our bottom layer, the melanin dimmer switch, comes into play.
Melanin cells have these crazy long arm-like extensions that reach up through the crystal layers. When a lizard wants to darken up, it commands the dark melanin pigment to flood outward, traveling up those cellular arms like ink spreading through water. This dark ink coats the upper layers, absorbing light and turning the lizard dark brown or black. When it wants to show off its bright neon colors again, it sucks all that melanin back down into the center of the cell, hiding it away so the crystal reflections can shine completely unobstructed.
So now we know how they do it, but let's bust the biggest myth of all. Why do they do it? Reason number one, it's a living mood dream.
Lizards use color to talk. It's aggressive, high-stakes communication. When two male chameleons face off, they don't fight right away. They blast their skin into neon yellows and bright oranges to say, "Look how big and healthy I am. don't mess with me. The loser of the argument will instantly flush their skin into dull, submissive browns to say, "All right, you win, I'm leaving." It's also how they flirt with females.
Number 2. Temperature control.
Lizards are cold-blooded ectotherms. They can't sweat and they can't shiver, so they use physics to regulate their body temperature. Cold in the morning? They flood their skin with melanin, turning dark to soak up the sun's heat. Getting too hot at noon? They switch to bright reflective colors to bounce the solar radiation away so they don't bake in the sun.
So the next time you see a lizard changing its color, remember, you are looking at a creature changing its pain. You are looking at a master engineer manipulating microscopic crystal grids, shifting wavelengths of light, and using quantum physics start to say hello to a Weber or warm up in the morning. Nature's tech is always light years ahead of ours. If you found this mind blowing, that like button. Subscribe for more deep dives into the weirdest science on Earth. See ya next time.